Good morning, everyone. My name is Jordan Dosu. This is Machine Learning CS422 for instructor Sun Jiangwen, PhD, and this is due on the 5th of December 2025. My project is on-device deep neural networks for face detection, a study inspired by Apple's Vision Framework. Introduction. Face detection is one of the most widely used applications of computer science, of computer vision, and machine learning, powering technologies such as smartphone authentication, augmented reality, and photo organization. This project explores on device face detection and recognition, inspired by Apple's Vision Framework and Face ID system, which perform deep learning inference directly on user devices for privacy and speed. The main problem addressed is how to accurately detect faces under varying lighting, poses, and occlusion conditions using compact, efficient neural networks suitable for mobile devices. The objective is to analyze how different neural network architectures and preprocessing techniques influence model accuracy while maintaining computational efficiency. Data description. The dataset used is the labeled faces in the wild dataset, which contains over 13,000 images of faces collected from the web, each labeled by the person's name. It includes diverse lighting, backgrounds, and facial expressions, making it ideal for evaluating face detection systems. This is from University of Massachusetts Amherst, and the features are grayscale and RGB images, facial landmarks, bounding boxes. I've gone over this in my project proposal discussion, so please watch that video. Machine learning methods. The project applies convolutional neural networks for face detection and recognition, focusing on lightweight architectures suitable for on-device inference. Methods include baseline convolutional neural networks, a 4-layer CNN trained for binary classification, face versus non-face, MobileNet v2, a pre-trained lightweight network optimized for mobile devices, transfer learning, using pre-trained layers from large-scale datasets, metrics, accuracy, precision, recall, F1 score, and inference time. Implementation. The programming language is, of course, Python. The frameworks I've used are TensorFlow and Keras, and environment is Google Colab GPU. Experiment steps. So first we do data processing, then we do model selection. Finally, we do training and early stopping and learning rate scheduling, and evaluation and latency testing. This is the simplified pseudocode. Algorithm 1, on-device face detection. Input image dataset x1, x2, all the way to xn, and the output should be predicted bounding boxes and labels. Results and discussion. After experimentation, MobileNet v2 achieved higher performance with minimal computational costs, aligning with Apple's on-device efficiency goals. As you can see, there was a comparison, and 91% with convolutional neural network baseline, and that was eclipsed by the accuracy of MobileNet v2 with shorter inference times, higher F1 score, and higher accuracy. The observations that this model takes are eyes, nose, and mouth, and lighting and occlusion. In this study, the conclusion is this project explored on-device deep neural networks for face detection inspired by Apple's Vision Framework, and results demonstrate that lightweight convolutional neural networks like MobileNet v2 balance accuracy, efficiency, and privacy for real-world applications. The future work could be applied to 3D depth data like Face ID, pruning and quantization, and study bias and fairness in detection. And I have my source code uploaded, and my PowerPoint and Google Doc, or sorry, Word document already uploaded. So this is VS Code showing you all the code that I've written. Ultimately, I my agent has run the program and has determined that the TensorFlow Lite model has the smallest footprint, the fastest inference, best accuracy, and hardware accelerator support. The data set is labeled Faces from the Wilderness, from the Wild, and that is each model goes for 10 epochs, which is a very long time. So I've already distilled the information here. Then pruning and quantization for models with significant size reduction. As you can see, the H5 took 25.13 megabytes. The pruned H5 took 9.56 megabytes, and TensorFlow Lite took 2.55 megabytes. These are again the evaluation metrics. There's a comparison between the three MobileNet models. And this is the Jupyter Notebook for the face detection models. Here is the README Markdown file. You can see the structure of my project. There's also a GradCam. And that's all. Thank you.